Question 16 says an object is placed at distance u from an equiconvex lens of mu equal to 1.5 and radius of curvature r equal to 30 centimeter, whose one side is silvered as shown. So this is the equiconvex lens and one side has been silvered. Column 2 contains the nature of image formed. Match the entries of column 1 with those in column 2. In column 1 we have different values of u, and column 2 is about nature of images formed. Well, what we do here is that we know we can replace this silvered lens by a spherical mirror, and we find the focal length of that spherical mirror. Okay, now the expression for the focal length of the equivalent spherical mirror is given as 1 by fm equivalent is equal to minus 2 by fl plus 1 by fm. This is the expression for focal length of the equivalent spherical mirror. Okay, now since the lens and the mirror both are converging, we should get a negative focal length. Now let's find then FL, and for finding FL we can apply the lens maker's formula, and the lens maker's formula tells us that 1 by FL is mu minus 1. Mu minus 1 is 1.5 minus 1 or 0.5 or 1 by 2, so it's 1 by 2 into R1 minus R2, and R1 here is 30 centimeter and R2 is minus 30 centimeter, so this is 1 by R1 minus 1 by R2, so it's 1 by 2 into minus 1 by 30 or plus 1 by 30 again. Let's simplify it still further. We see that's 1 by 2 into 2 by 30, so we can see that the value of FL is 30 centimeter. Okay, so let's put it here. It's minus 2 by 30, and the focal length of the mirror will be minus 15 centimeter, so it's minus 1 by 15. Let's do the addition now. It's 30, LCM is 30 minus 2, and this is also minus 2, so we are getting FM equivalent as minus 30 by 4, or simply minus 7.5 centimeter. So this silvered lens is going to behave like a concave mirror of focal length 7.5 centimeter. Okay, so now just to solve further, that is what we are going to consider. Now if object is at a distance of 20 centimeter, so it is clearly beyond 2f distance, right, from this equivalent spherical mirror, because the focal length is coming out to be 7.5 centimeter, and if the object is placed at a distance of, we simply say it's beyond C, right? C itself is at a distance of 2 times f, where f we are taking the modulus of the focal length, then the image is real and it's also diminished. So for A, image is real and diminished. So that means for A, P and S will match, and for B, when U is 10 centimeter, it's something like the object is between the focus and center of curvature, right, for a concave mirror, and in that case we know image is real and enlarged. So for B, real and enlarged will match, so it matches with P and R. Now for C, it's like the object is between the pole and the focus of a concave mirror. We know that in such case image is virtual, enlarged, erect. So for C, virtual and enlarged will match, so that means C matches with Q and R. And for D, it's like the object is at the center of curvature, the image is real, inverted, and has same size as that of the object. So that means for D, image is real will match, so P matches and image is of same size as that of object, so T will also match. So this is our matrix match for question 16. Let's go to the next question now. Question 17 says match the entries of column 1 with those in column 2. In column 1 we have entries like a charged particle is moving in only uniform magnetic field, a charged particle is moving in only uniform electric field, a charged particle is moving in uniform electric and magnetic field, and a charged particle is moving in uniform magnetic field and gravitational field. In column 2, entry P is path of particle can be straight line and so on. So let's start with entry A in column 1, which says a charged particle is moving in only uniform magnetic field. Well, if a charged particle is moving in a uniform magnetic field, then path of particle can be a straight line. Well, we know that this statement is true because if the particle is moving parallel or anti-parallel to magnetic field, then the magnetic force is going to be 0, and in that case particle will be moving in a straight line with uniform velocity. So we can see that A matches with P. Then let's look at entry Q, whether it matches with A or not. So Q says path of particle can be circular. Well, we also know that if the charged particle is moving perpendicular to a uniform magnetic field, then in that case its path will be circular. So that is if the angle between the velocity vector and magnetic field vector is 90 degree. In that particular case path of particle is circular. So Q also matches. Let's look at R now. It says path of particle can be helical, and this is also true. The condition is that the angle between velocity and the magnetic field, if it's not 0 degree, if it's not 180 degree, or even if it's not 90 degree, if it's none of these three values, in that particular case the path of particle is helical. So R matches, and speed of particle may be constant is true because magnetic force, even if it's acting, does not change the kinetic energy, and so speed of particle does not change because of magnetic force. So S also matches. So for A, P, Q, R and S, they match. Speed of particle may be increasing, will not match for the reason I just mentioned. Let's now look at entry B in column 1, which says a charged particle is moving in only uniform electric field. Well, if charged particle is moving in only a uniform electric field, that means there is no other field in that area. So in that case path of particle can be a straight line. Well, it will be true if the velocity of particle is either parallel or anti-parallel to the uniform electric field. In that case path of particle will be a straight line. So B matches with P. Let's look at Q now. It says path of particle can be circular. Well, in a uniform electric field the path of particle cannot be circular. It may be a straight line, it may be parabolic, but it cannot be circular. So Q does not match, and R also does not match. S, speed of particle may be constant. Well, this is also not correct because the electric force will be doing work on the particle and its speed will change, its kinetic energy will change. And T says speed of particle may be increasing, which is correct. It in fact matches with B because, as I said, the electric force will do work and that will change the kinetic energy. So it can increase the kinetic energy, it can decrease the kinetic energy. So the speed may increase. So that means B matches with P and T both. Let's look at C now. It says a charged particle is moving in uniform electric and magnetic field. If that is the case, then path of particle can be a straight line is correct, and that is the case when the magnetic force and the electric force cancel each other, right? So if magnetic force and electric force on the charged particle cancel each other, in that case particle moves in a straight line with uniform velocity. So C matches with P. For this reason it can move in a straight line. Let's see Q now. Q says path of particle can be circular. When there is both magnetic field and electric field, then path of particle cannot be circular. So Q does not match. Path of particle can be helical. This is the case when electric and magnetic field both are parallel. In that case, the path of particle can be helical. Okay, so if electric and magnetic field are along same line in that particular case, and if velocity has a component perpendicular to these two, in that case path of particle is helical with a changing pitch. So R matches with C. Let's look at S now. Speed of particle may be constant. In fact, in the case when particle is moving in a straight line with uniform velocity, when electric and magnetic force cancel each other, obviously the speed of particle will be constant. So S also matches. And speed of particle may be increasing, clearly matches, because the electric force will change the kinetic energy, and in that case speed may increase. So C matches with P, R, S and T. Let's look at D in column 1 now. It says a charged particle is moving in uniform magnetic field and gravitational field. Well, the gravitational force will also do work similar to electric force, which means that gravitational force can change kinetic energy, and similarly if the magnetic force is equal and opposite to the gravitational force, in that case path of particle can be a straight line. So in fact in this particular case, whatever is applicable for uniform electric and magnetic field for the charged particle is also applicable for a uniform magnetic field and gravitational field as far as the options in column 2 are concerned. So that means for D also same entries will match as for C. That means for D we have P, R, S and T as the correct matching entries. Let's now go to the next question.